You're live on Facebook now.
Yes, that's fine with me.
Very good. So we started live streaming to Facebook Co-Creators Convergence. Normally, I should have Sarbmeet's bio here. Let me get it and make a proper introduction. Sarbmeet, we've had Sarbmeet present at Co-Creators Convergence, and we've been seeing Sarbmeet in different events and sessions of the Deep Time Leadership. Sarbmeet Kanwal has a PhD, is an award-winning educator and a pioneer in novel ways of teaching quantum physics and astronomy. He holds a PhD in theoretical physics from California Institute of Technology. His aptitude for explaining intricate scientific concepts in everyday language has made him a sought-after speaker among both science and non-science communities. I know that in the Deep Time Network community, Sarbmeet is looked up to for his facility in articulating, concepts that can be rather obscure. I particularly like the way he talks about when we talk about the universe or the cosmos expanding and the planets moving from each other. He says they're not really moving. It's like raisins in a bread that's growing. When you're cooking a bread, it's the bread that's expanding. It's not the raisins moving away from each other. Sarbmeet, on that note, I will pass on the mic to you.
Thank you very much, Tex. And in fact, I will be talking about those raisins again today. Okay, so let me share my screen and make sure that indeed the technology is working, because you never know. Okay, I hope it's all fine. In case it isn't, please let me know.
It's good.
Okay.
It's good.
All right, excellent. So the title of my talk is a bit audacious. And so let me say a few words before I jump in. First of all, I wanted to kind of resonate with what Jennifer said, that we think we know the universe, but we really don't know the universe. And the universe indeed is a big mystery. And so I want to let you know that I'm not going to answer that mystery in this talk. But what I'm going to do is to introduce you to a little bit more of the science that we know about the universe that many of you may not have heard about. I think everyone that is associated with deep time, and maybe even if you're not associated with deep time, you have heard about the Big Bang Theory, and you have heard about how our universe was created from this fireball that started it all. But very little, if anything, is usually said about what created the fireball. And that is the question, and I know it's an audacious one, that is the question that I am going to address today to the extent that I can with the scientific knowledge that we have today. And I should also tell you that, we come to these talks looking for answers to our questions. And I certainly hope that you will get a few answers. But I would feel that my talk has been successful if you leave today with a couple of really good questions. because it is those questions that actually allow us to continue our seeking. And so I think that in some ways, questions are actually more important than the answers. Okay. Make sure that I can advance my slides. There we go. Okay. I hope you can see the slide okay. So I'm actually going to do this talk by telling you two stories. The two stories are intertwined with each other. They're related to each other. One of the story is a human story, and the other story is the story about our universe. And you will see at the end that these two stories live inside of each other. Now, the human story is the story of how we figured out what happened before the Big Bang. And so that is the science behind what I'm going to talk about today. And all of that happened in the last 40 years or so. So that is really a 40-year story. Now, the story about the universe that I'm going to talk about is not the 14 billion year story that you've been hearing about. I'm actually going to talk about a story that happened in a really, really tiny amount of time. In fact, it happened in the trillionth of a trillionth of a trillionth of a second. That's how small it was. And that's the story about what happened before the Big Bang. Now, for each of these stories, I'm going to have rather long prefaces so that you can get a background of how we ended up with this incredible inquiry that science has been able to lead in order to answer these incredibly mysterious questions. So what is the topic of my stories? It turns out that the topic of my stories is actually nothing. And I'll tell you what I mean by that. So the question that was asked about 2,500 years by Greek philosophers was, does nothing really exist? And the reason that people had doubt about nothing existing was because there was a general feeling that anything that really exists in our universe must have at least one property that you can refer to. And folks said that nothing cannot have any properties because it's nothing, and therefore nothing does not really exist. However, there was lots of debate about that because some people said that if nothing doesn't really exist, then how is it that we can move through space, because space is, generally considered to be the nothing. And people had answers to those questions, and they said, well, fish can move through water, and even though water is there, it doesn't obstruct the fish from moving, it just parts its way as the fish move through it. So water can be a something, and yet, it can allow movement as it is. So the first thing I want to make clear is, people might be wondering, what do I really mean by nothing? The ordinary definition of nothing, which is what I'm assuming here, is that nothing is simply a place where there is no matter. And that means not even air, nothing at all, no molecules, no atoms. If you take everything, if you suck the air out of, this room that you might be in right now, what would be left would be nothing. So that's what I'm really talking about when I talk about nothing. So our story from 2,500 years ago jumps right to about 100 years ago, because between that time, nothing really happened to throw any further light on what nothing was. The debate continued. In fact, Newton and Leibniz were two philosophers of their times that continued this debate. Einstein, however, found an answer. And the answer that he found was not because he was looking for one, it was because he was looking to find something completely different. He was looking to find the correct theory of gravity, because he knew that the theory that Newton had come up with could not be right because it violated some of the things that he had discovered. So he was looking for the right theory, and in that process, he wrote an equation, and that equation was actually an equation of nothing. It was an equation that described space. And when he solved that equation, he found out that space is not only a something, but it is a something that actually wants to continue to expand all the time. And he was very dismayed because during his time, there was a belief. And here is where I want to tell you that science, even though it prides itself in being evidence-based and unbiased, actually falls into the same trap that so many of our institutions do, that it also develops a dogma, a doctrine. And the doctrine that had been developed in science was that the universe had to be eternal, that it had no beginning. So Einstein actually ended up modifying his equation in order to somehow make that expansion go away. There were other people, though, who wanted to continue to believe in it and to see what it would lead to. And one of the first ones was Georges Lemaitre. George was actually both an astrophysicist and a Catholic priest. And he took Einstein's equations and he said that if this is really true, then there must be a moment of origin. Because if you work the universe back, and if it is expanding right now, there must have been a time when it was either just a point or very, very tiny. And Einstein didn't like that at that time because, you know, the quip that he made, which I have on the slide, to George was, your math is correct, but your physics, he said, is abominable. Well, anyway, Einstein did have to eat his words because just a couple of years after this, Hubble, who was an astronomer, was able to show through his telescopes that galaxies were indeed moving away from each other, which indicated that perhaps the expansion that Einstein had discovered was true. There's a little aside here that I have on this slide, which is when this was going on, the Pope immediately declared that science had found a proof of God. And Lemaitre, the good physicist he was, wanted to make sure that this debate would not end up in hurting religion. So he actually wrote a stern letter to the Pope and told him, nope, don't get into this one. Well, anyway, the doctrine that had been established in science was quite rigid. And for the next 40 years, even though people like Hubble and even Einstein at this point, you know, started to believe that perhaps this is how our universe started, the mainstream of science did not want to believe it. And for the next 40 years, despite some growing evidence that this was indeed true, the scientific community kept finding different ways to negate it. They always seemed to find another way in which they could explain the moving away of the galaxies. In fact, the word Big Bang, not too many people know, was actually a derogatory term that was spoken out by one of the champion opposers of the theory. And in a broadcast on BBC, he actually referred to those weird people that think that the universe could have started with a Big Bang, and the name stuck. And that is how, you know, we call this today the Big Bang theory. Here's my raisin picture that Tex was talking about. So the important thing to understand about the expansion of the universe is that the reason that the galaxies are moving away from each other is not because they're moving through space. It is the space that is expanding in between them. And there is a very important difference here that we should understand. And that is why, in fact, you know, we are talking about space as a nothing that is not a nothing, that is a something that can expand and contract and do many other things. So what this diagram shows is that if you think about a raisin bread, and I know that raisin bread is an American term, so some of you may not even know what I'm talking about, but basically it's a bread which has raisins embedded in it. And so when you bake the bread, the batter expands and the raisins, of course, move further away from each other. And the important thing is that the raisins themselves are not moving through the batter. The batter is expanding between the raisins, and that is exactly how space expands between the galaxies. And so this is, you know, what needed to be established, that this is indeed what was going on. So what we needed was irrefutable evidence. And what we needed was other clues and other hints that would tell us that this was indeed true, that the universe did really have a beginning. So it turns out that there is a very brilliant way in which you can look for these clues. And the way that you do that is you turn the clock back on the universe. And then you figure out what must have happened in order for the universe to be where it is today. Now, I want to tell you that this is not something that you can do with every kind of evolution. For example, if I was to take biological evolution, I can't turn the clock back to figure out what happened, because most of biological evolution has taken place in random ways in which, genes mutate, and they mutate randomly, and something survives and the other doesn't. And so you can't figure out exactly how that happens. So what do we do with biological evolution? We look for fossils. And everything that we know about how we came here in terms of our biological evolution has been found out through the process of finding those fossils. Luckily for us, we don't have to do that with the universe itself. All of the mechanisms which evolved the universe, which is really the laws of physics, the equations of physics, those equations are reversible in time. So all I have to do is to change the time into negative time, and I can see exactly what would happen. And this is an amazing thing that helps us to figure out how the universe came to be the way that it is. In fact, a smoking gun, which is what people were looking for, was discovered in 1948 by Ralph Alpher. Unfortunately, he was a young Jewish immigrant physicist. And, as our world has it, there are certain kinds of people that don't get as much attention as others do. And his work was largely forgotten. But what did he do? Let me tell you that. So let's rewind the clock and see what happens. So what happens, first of all, is all the galaxies come closer and closer to each other until they become one big mush. And that mush is now nothing but a huge amount of hydrogen gas. Now, one of the interesting things about contracting the universe, which is what happens when we reverse the clock, is that it also heats up. That's simply what the laws of physics tell us. And so as the universe is getting smaller, it's getting hotter and hotter as well. So what happens to this gas of hydrogen molecules is that, first of all, because of the heat and the energy associated with heat, in fact, heat is nothing more than just motion energy, the energy actually ends up breaking the molecules first into the atoms, and then the atoms themselves break up. And here at the bottom, I have a picture of a hydrogen molecule and a hydrogen atom. And a hydrogen atom has an electron going around a proton at the center. So as the temperature increases, the electron is stripped off from the atom. And what you get is a proton and electron separately moving around in a kind of a gas. Now, here's an interesting thing. When you have protons and electrons moving around separately, you get what we call a charged particle gas. And a charged particle gas is opaque to light. Light cannot penetrate it. This is something that we know from our physics experiments here on Earth. However, when an atom comes together into a neutral thing, which is what it is, then suddenly that gas becomes transparent to light. And so this is what Ralph Alpher found, that if you go back, you can figure out exactly the time that this happened and the temperature that it happened at. And in fact, the temperature is about 3000 degrees Kelvin, which is basically the same as Celsius. And it is at that temperature that the universe would suddenly become atomic, because atoms can then combine with the protons. So therefore, there should have been a huge amount of light that was produced at this time. And this time is about 3,800 years after the Big Bang. And that light should still be here, and we should be able to see it. Now, it also turns out that when you look at what happens to light in an expanding universe, you find that the light also stretches. And therefore, the light, which was very visible at the time it was released, now becomes not ordinary visible light, but it becomes microwaves. So if you want to look for this light, you have to look for those microwaves. And of course, even after Ralph had told them that, most people just ignored it. And as it turned out, this light was discovered purely accidentally, because here where I live, just a few miles from here, is an antenna. And that antenna was owned by Bell Laboratories, which turns out is a place that I worked in for 30 years. And at Bell Laboratories, people were doing some experiments in communication, and they built this antenna to do that, and they kept getting noise, and they didn't know where the noise was coming from until They kept looking and looking, and finally someone in Princeton who knew what was going on told them, this is not noise, guys. This is exactly that smoking gun that we'd been looking for. And it was after this that people really started to believe in the Big Bang, and much more work and research was done on it. So here is one other thing that is an even stronger proof of the Big Bang, and that is the composition of the intergalactic gas. This is the gas between galaxies, which has never been turned into stars, and therefore it has never gotten polluted, so to say, with all the dust and stuff that gets created inside a star. So this gas is exactly the gas that came out of the Big Bang. And when we look at that gas, we find certain abundances, percentages of different elements in them, which are kind of peculiar. It turns out that hydrogen is about 76%, helium is about 24%, but then there are these other atoms that are made up of, a couple of protons or a couple of proton and a neutron, and they have very tiny abundances which can be measured through our telescopes. And now here is the amazing thing. If we keep going back and rewinding the clock to look at what happened to our universe earlier, we find that these atoms were assembled much earlier in the universe at a much higher temperature, in fact, about a temperature of 100 million degrees. This is even higher than the temperature in the core of the sun. And this is where what we call nucleosynthesis, which is the synthesis of nuclei, takes place. And we can actually work this out in our labs as to exactly what percentages of these atoms will be produced during this process of nucleosynthesis. And the amazing thing is that the percentages come out exactly what has been seen by telescopes in the gas. So this is considered one of the most foolproof ways to know that there's really no other way in which something like this could have happened other than the Big Bang theory, which is, the basis of our cosmic story today. So we can continue to go further and see what happens, because we want to get to the point before the Big Bang, and there's still a little ways to go before we get there. So let's continue to rewind the clock to see what would happen. So the thing that we now know is that protons and neutrons, which is what nuclei of atoms are made up of, are themselves made up of smaller particles called quarks. And so if you keep heating the universe, these quarks get stripped off, and what you end up is with the most elementary of the elementary particles. And these are quarks and electrons. In fact, I failed to tell you that there are really two kinds of quarks only. So a proton is, and they're called U and D. That's just what they're called. A proton has two U's and one D, and a neutron has two D's and one U, but there's only two kinds of quarks. And so these two quarks and the electron are the three elementary particles from which the whole universe is made. That's it. That's it. The three particles make up the whole universe. And so if you go back further into the universe, what you end up with is nothing but a soup of these particles. Just sort of juggling around all the time, that's what happens when you have something very hot. It just keeps moving and jiggling around, and that's exactly what happens. So this is, where we get to as we keep going further. Of course, we're not going to stop. We're going to continue to move further. So if you increase the temperature even more, something really strange starts to happen. The energy in the particles in the radiation actually is so high at this temperature. Now we're talking about not only millions, but we're talking about billions of degrees Kelvin. That's the temperature we're now coming to. At that temperature, the energy automatically starts to convert itself into pairs of antimatter and matter particles. And so you get loads and loads of these particle and antiparticle matters until the point then the actual particles that make up our universe becomes a tiny anomaly. In fact, it's so tiny, it's 1 in 10 billion. All of the other antimatter and matter particles that are in the universe at this point are simply created out of energy. They have nothing to do with the universe at all. In fact, if you keep heating it up, we now know that even the small anomaly slowly disappears, and you get something that is a more symmetric universe, which is a universe that has an equal number of particles and antiparticles in it. And so now the amazing thing that happens is that we don't have to worry about rewinding the universe anymore. We are now in a place that is independent of the universe, And so if we can create these kinds of energies on Earth, we can actually study what happens to the universe independently. And that's exactly what we have done, through which we have made some incredible discoveries. So this is what I was talking about. The anomaly disappears, and we can actually go to our particle accelerators, and we can create the same temperatures and energies by hitting these particles together, and we can find out exactly what happened at the beginning of our universe. So what are we using now to figure out what is going on in the universe? What we are using is the principle, the laws, the organizing principle of the universe. What we are finding out now is what that principle of the universe will create in the universe. That is what is now in operation now. And therefore, what our focus is going to be from now on is what we call the organizing principle of the universe, which is basically the law of the universe. And I sometimes shorten that to OPOTU. OPOTU has just a nice ring. But that's where we are at now, is to uncover what this organizing principle is. That's become our pursuit now. So if you look at the organizing principle, you find out that it has 4 fundamental forces hidden inside of it. And we've known this for a while. And these are all of the forces that we know of that operate in our world today can be traced back to these 4 fundamental forces. These are the roots of the forces. That's where everything that we know comes from. And that's what the organizing principle tells us, that these are these 4 fundamental. And I put them out here. Don't need to worry about the names much. So we can now go on to see what would happen to these fundamental forces, because that's what we have, that we have the organizing principle now, and it consists of these 4 fundamental forces. And something really amazing happens as you try and look to see what, as you try to increase the temperature again and make the universe smaller and smaller. So the first thing that happens is that there are 2 forces called electromagnetism, which is basically magnetism and electricity that you all know about, and something that you may not know about called the weak force. They come together in a unification. They become a single force. If you heat the universe further, another force comes into play, which is called the strong nuclear force, and that merges with it. You get the second unification. And then as you keep going, the 4th force, which is gravity, merges with them, and you get the 3rd unification, and you get a single unified force at the end. I have to tell you now that part of this is very well established and understood because we can recreate it in our lab, and part of it is somewhat speculative. And the speculative part of it is well understood in terms of its mathematics and its equations. So we have a good, reasonable idea that we are on the right track with it. But there is still more work that would need to be done to establish that as a fact. And to tell you, where we are in terms of our temperatures now, we're talking about trillions of degrees Kelvin, trillions of degree Kelvin, which is where the 3rd unification takes place. Now, here is something that I'm going to introduce, and I'm going to tell you what the Big Bang is and where it happens, because this is now where we're going to go before the Big Bang. So what is the Big Bang? Well, it turns out that the modern definition of the Big Bang is the time between the first unification and the second unification. That era is called the inflation era. And we know that during that era, the universe expanded tremendously in a very short period of time, which is a reasonable thing to call a Big Bang. That's when the fireball really exploded. So that is the Big Bang. And the question is, can we go behind that and to see what happened there? So here's a picture of what you could conceive of as the Big Bang. Just to give you a little bit of the factual stuff here, which is kind of mind-blowing. The universe grew by a factor of 1 trillion times trillion. It grew from a size that is very tiny compared to even an atom to the size of about a grapefruit. That's what happened during this era, the inflation era, the Big Bang. And all of that happened in less than a trillionth of a trillionth of a trillionth of a second. Yes, indeed, we can calculate these things. You might be kind of skeptical and wonder, how can we even talk about times as small as that? But we can. So here is the story, the 40-year story that I've been building up for, the 40-year human story, is that in 1980, a guy by the name of a physicist by the name of Alan Guth, he was trying to actually figure out how the matter in the universe was created. And he again stumbled upon something very interesting. He found out that if you take a quantum field and if you cool it very suddenly, then the energy in that field gets stuck in a certain place. And then at a certain point, the energy is released. And when it is released, it actually causes the space to expand at a tremendous rate. And in fact, in the same process, it actually ends up creating matter. So Alan was able to find out where all the matter in our universe came from. Now, why do we believe that this is what happened? Well, first of all, the reason that inflation has become such a popular thing is because it solved some long-standing problems with the Big Bang theory. There were some dilemmas and puzzles that existed in the Big Bang, which nobody was able to understand. With inflation, we are able to answer all of those questions. The other thing is that over these last 40 years, the evidence that inflation was indeed how our universe was created has been growing rapidly. And so the mainstream physicists now very much believe that this is how our universe suddenly blew up, which is what the Big Bang was. So here's another diagram, and I kind of apologize a little bit because all of this time I've been talking about the universe, the time going from left to right, which is the Big Bang on the left side. And then as you saw, the funnel keeps expanding, which is the expansion of the universe on the right-hand side. Well, here I've inverted it, so you might get a little confused, but just makes it a little easier to understand what's going on. So as you keep heating up the universe, what you're getting, as I have mentioned, is the unification of these forces, and that is what is being shown in this graph. And some interesting things happen at each unification. For example, the first unification actually causes all the particles to lose their mass completely. So everything becomes completely massless, which basically means that everything becomes like light. The thing that we know from physics about light is that light is made up of massless particles. And that's why it has the wonderful properties that it does. But everything becomes like light in this first unification. In the second unification, all the particles disappear from the universe. All that is left is light and radiation. That's all that is left there. In the third and final unification, which is also called the grand unification in physics, what happens is that space and time also completely disappear. There's no space, there's no time left. And along with that, gravity as a force disappears because it now is combined into this single force, which I'm going to call the single force or the one force. And so all that you're left with here is nothing material, not even space and time. This is another definition of nothing, if you will. All that you're left with is the organizing principle, period. That's all that you have. So what is this organizing principle of the universe that started it all, right? It's basically a mathematical equation. It's not anything that you can hold in your hand, but it has a power. It has a power to predict all the possibilities that can be generated from that principle, that can be manifested from that principle. Now, this is what science is left with, because if you take the organizing principle away, you really have nothing left. There is no science anymore because science uses the organizing principle to predict what's going to happen. And so if you take that away, then there is nothing. And so this is really that mystery that Jennifer was talking about. It's there. It's not going to be taken away. It's always there. Science cannot remove that mystery. But what we believe is that this organizing principle is the thing that governs our universe, and it describes this unified force that I talked about. And I'm going to talk about this force, it's kind of like an acronym. One force is what I'm going to address this as. So what is this one force, the beginning of the universe, the organizing principle? It holds within it all the possibilities of the ways in which this can be manifest. All of this is very quantum mechanical. It's understood only through quantum physics. And so, that is what has helped us get to where we are today, is quantum physics. So all of the possibilities of manifesting into physical reality are held inside of this organizing principle, the one force. And like every force that we know of, it has affinities. That's what a force is. It's an affinity, right? So there are some possibilities towards which it has more affinity than others. I mean, it's like, think about a force in our everyday life. Let's talk about a force where I push an object forward with my force. Well, the chances are that the possibility of where that object is going to end up is in the forward direction. not in the backward direction because I'm making the push force forward. So there are some possibilities that are more likely to happen. The same thing is true here. So indeed, what we are now finding out is that our universe is an evocation. It is not caused by anything. There's no reason. It's an evocation that simply happens from the principle, because that's what quantum physics tells us, that if you have a principle, it will automatically make certain things happen. And the thing that happens with this particular principle is that it evokes a whole universe. And it evokes a certain kind of universe. It evokes a universe that will end up with butterflies and zebras, not a universe that's going to die perhaps in a few hundred years, with giving no chance to something like this happening. And indeed, there are such universes that you can create as well, but they will not survive. So the one force, what does it do? It actually falls from its oneness and perfection, right? Kind of a very biblical, almost connotation to something like that. It falls from its perfection in order to evoke the universe. But the important thing to understand here is that it is not a transformation. It's not like something is transforming into something else. It's really an evocation, which means that the one force doesn't go away anywhere. It's always there. In fact, the truth is, and physics tells us this, that if I today go into the space that is in front of my nose, and if I go further and further and deeper into that space, which is kind of what a particle accelerator does, I will recover all of those stages of evolution that the principle went through in the beginning. All of them are right there under my nose in there. So this is what I mean when I say it's a story inside a story, because this story about how the universe started is actually inside of us. In fact, the most amazing thing that was discovered in the last couple of decades is that if I take all the protons inside my body, because the protons are so tiny, so therefore they are something that has such a small scale associated with them, they actually they reproduce an era in the evolution of our universe, which is when we had this particle soup. You remember the quark electron scoop that I talked about? And so it turns out that if we take the quarks inside the protons, which are only 3 quarks, and we add up their weights, it comes out to 5% of the weight of the proton. All the 95% of the weight of the proton is because of that particle soup, the same soup that happened a trillionth of a second. It's all in there. 95% of our mass is created by that soup that was in the fireball. Amazing, amazing discovery. Okay, I'm moving towards the end here. So that was the human story. What is the story about what happened before the Big Bang? That's what we're talking about now. And so the story is about a force. It's about an allurement. And so if I look at it, if I invert my chart and now put the one force in the beginning as the starting point and then move towards the right, what we get is a complexification of these forces. So the same forces, the 4 fundamental forces, now become derivative forces. For example, the forces that attract atoms to molecules are not the same force that brought the atom together. They're derivatives of that. They're complexifications of that. Further complexification attracts molecules together to make bigger molecules. Further complexification attracts these molecules to make living cells. Further, complexification of this allurement, this force, creates an organism, and so on and so forth, right? It's the same force that's getting complexified with evolution, just the same way in which matter is getting complexified in order to form more and more complicated forms. We start with particles and we create more and more things with it during the evolution. The whole cosmic story is about that. But what we don't always understand that is, along with the change in the shape and form of things, there is also a change that is going on in the forces that run the universe, the allurements that run the universe. So in the end, the allurements that we feel are nothing but the complexification of that original allurement. So this is why I put at the end of it, a mother and a baby. That bond, the mother-baby bond, is a complexification of that same allurement with which our universe was born. So I say here, when you go tonight and hug your child, think about that. What is attracting you is indeed a complexification of that one force. And this is the last slide. So here's, the subtitle of my talk was it's what is the cosmos asking you to do? What is the call of action from the cosmos? So if you really want to know what that call of action is, what is the cosmos asking you to do? What is that next step in bringing our Earth together, the Ecozoic era and so forth? Well, you have to go and look deep inside of you, because that is where the complexification of that allurement is hiding, and it's different for all of us. So if you go inside and find what that allurement is and bring it up and express it in your life, what you're doing is the calling of the cosmos. That's what it's about. So this is my talk, but before I go into Q&A, I would like to share with you something that I wrote, which is something that welled up inside of me as I mulled over the story that I told you today. So it has a lot of those elements in it, but told in a poetic form. I'm no poet, but this is something that I, was able to pull together. This is my first attempt. So I'm gonna share my screen again. And let me see. Let me try one more time. Not sure if I got this right. So share my screen. Okay, hopefully this will work. You may have to turn your volume up so that you can listen to it. If you do have an issue with not being able to hear, please stop me and let me know and I can try again. I'm hoping that this will work. If I can get it going. I'm not able to get to the play button because it's hidden behind these things that I can't get rid of. Let's see.
Try to expand it maybe to full screen.
Yes, that
Yeah,
might
if I can maybe, I think I did it. I moved that thing up there.
Okay.
So
Great.
now it should work. Now it should work. All right, here we go. Here goes. Oops. Here, one more try. Okay. Can you feel the love tonight? The untold part of our origin story. This is a story about how the story began. It is about what happened before the bang, before the fireball, before the flaring forth, before the great expansion that became our universe. There was at first no space, not even any time. There was no physicality. It was a world sublime. Within the abstraction, there lay a rich perfection. All the fundamental forces were in deep connection. It was a kind of nothingness, the ground of all being, a sort of empty fullness with nothing there but dreams. The dreams are all possibilities of what it can become. They cover all the likelihoods of what is yet to come. The possibilities come and go, dancing in and out, moving faster than light. They're impossible to count. The spirit that seems to move them so is restless as a child's. Its nature is to seek and explore with a disposition that's wild. These unstoppable agitations are called
quantum fluctuations. They come in all shapes and sizes, and they have no limitations. Cause and effect, and Newton's laws, for them have no meaning. Beyond the reach of space and time, for them there is no ceiling. This constant hum, does anyone know whence it doth come? To Hindus a sound of Om, to physicists a quantum vacuum, a wholesome unity, a singular oneness, and a perfect symmetry. For us worldly humans, this spirited abstraction is a total mystery. And then it happened. The spirit, while exploring, saw a dream that was so awe-inspiring. It was wild and ambitious and very alluring. The spirit was in love. Its heart was soaring. The dream was brilliant, dazzling, and so much more. It was beautiful, captivating, something to die for. There was love, there was passion, and a burning fire. What was this dream that evoked so much desire? It was flowering fields under clouds so high, snow-capped mountains against bright blue skies. Vast grassy meadows dotted with sheep, gentle rivers flowing into oceans deep. It was thick green forests, laced with blue streams, speckled butterflies hovering in sun's shiny gleam, and a humming, buzzing world full of human beings, braving their imperfections and living their dreams. This amazing dream, it must be achieved at all costs. It was worth every risk and peril that lay on its path. It'd be a long journey with no chance of coming back. Once begun, it must be followed to the end of the track. Spirit leaped into the unknown, and onward it went, breaking all its peaceful symmetry for a risky event. Driven by a fiery passion that stirred within, it was prepared to take all chances that lay therein. Creating space and time was as easy as pie, but filling it with matter, the difficulty was high. Empty space can naturally grow and expand. To fill it with butterflies, we need something grand. It was then that another fluctuation brought a vision forth. Pour as much energy into space as its emptiness can afford. It meant breaking another symmetry that had long endured. But if the result was flowers and zebras, then spirit was lured. Energy fluctuations in empty space had already borne some fruit, but the particles were virtual. Of that there was no dispute. For matter to emerge, physicality must take birth. Particles must become real to build heaven and earth. It had to happen. Another quantum leap was provoked. The energy spread so rapidly that inflation was invoked. The universe swelled 1,000,000,000,000 times and another 1,000,000,000,000-fold. It all happened in the split of a second, too small to behold. Flaring forth it was, but some called it Big Bang. It was the tiny fireball from which our universe sprang. Every particle in the dream was where it needed to be. With some unfolding, it would turn into star and galaxy. 14 billion years it took to make the dream come true. The fiery love that brought it forth is inside me and you. To see the love, you must connect with the spirit deep inside. Try it now and tell me, dear, if you can feel the love tonight. The restlessness is still all there. The dream is yet alive. This is just a resting place beyond which it needs to thrive. Love that sprang in a quantum field is now for us to ride. So move the spirit forward, dear. Take the next big stride. Thank you.
Thank you, Tex. Back to you.
Thank you, Sarbmeet. And that's, as someone said, this is awesome. Yeah, that's what I was going to say. To leave us with awe and we wonder. We're not wondering, but we wonder where we're heading. I mean, I wonder, was there an alpha consciousness behind all this? What do you think?
Say that again, Tex. What is behind it?
An alpha consciousness. Was there an alpha consciousness behind it?
I get it. I get it. I get it. I actually don't like to use the word consciousness in this context because, you know, like the word God, consciousness has a lot of baggage and there are many interpretations of what consciousness means. What I prefer to say is that there is an intelligence here. There is clearly an intelligence here that could create something like what we see today. Cannot imagine how it could just happen randomly. So that is my way of saying it, that there is an intelligence behind this.
Okay, thank you. That's wonderful. Any other question? We have up to the top of the hour. Now, if I may say, we're running straight through to 6 EDT. We're live streaming to Co-Creators Convergence. The next speaker is already here. It's Yona Frenchhawk, who will be introduced by Hasina. So if anyone wants to take a little break, we can engage with Sarbmeet to the top of the hour. In the meantime.
Thank you. Thank you.